My name is V88 Gutesman, and I work at Core. And I'm about to present a work we made with Ariel Futuransky and Ariel Waissbein. And, well, let's start. In this talk, we'll talk about mainly a protection to protect web applications against injection attacks and enhance privacy. And the talk will be organized. We'll first make a brief introduction. Then we'll talk about known tools to address injection problems. Then we'll present the classical taint mode, and that kind of motivates our work. And then we'll compare it with character granularity information. Then we'll introduce our project called Core Grasp, and then we'll talk about future work. So maybe some of you are familiar with the things I'm talking in the introduction, so I ask you to be patient. Maybe some of you are not. So we're talking about injection attacks and why we will have to be worried about them, and the objectives and results, the objectives that motivated our work. They will start a demo that will be running while the presentation goes on, describe the threats and the countermeasures that are known. So every day, injection vulnerabilities are discovered. So most of the exploits that exploit these vulnerabilities make use of these weaknesses, and the exploitation of these vulnerabilities can lead to different threats. For example, data theft and alteration, impersonation, also remote code execution in clients' browsers. So one of the problems is that as programming languages evolve, and while they'll lower the curve for new programmers to start developing web applications, at the same time they fail in introducing mechanisms to prevent injection attacks. And you also can find that privacy can be compromised through these attacks, and we need some policies to protect them. So which were the objectives of our work? We wanted to develop a technique so that it protects all web applications without requiring to modify their source code, and neither major changes to its network architecture. So injection attacks must be detected and may optionally be blocked. This should be configurable. And it also must allow the owner of the web application to define policies over data. And this system must enhance privacy over this data. So one important aspect of these objectives is that if we want to detect and block injection attacks, we must be very accurate. Otherwise, we will fall into a big amount of false positives. So we don't want it. So what we design is a technique which allows us to detect injection attacks and also privacy violations, which is called GRASP. And we've been working on this for a few years now. We have a prototype for PHP, which is called GRASP for PHP, and that we are releasing today as an open source software. So to illustrate a simple SQL injection example, we have a login. So a user comes into our website and logs in, typing his username and his password, and later this goes into the web server, and it's used to query a database management system. And well, maybe this is a very simple query, but it will do well for our example. So the values then the user entered are concatenated into the query and used to authenticate it, to authenticate the user. But what will happen if the user enters something different than a regular username? For example, a very common way to illustrate SQL injections are adding some tautologies to the where clauses, modifying the query, so it will always hold the condition, and any user could authenticate. So now we're going to do a demo about our work. So we have two copies of the same PHP version. One of these is patched with our solution. We'll first install the original copy of PHP, and then we'll test a public exploit against a popular CMS. This exploit exploits a blind SQL injection, which is a SQL injection which we cannot see the output, but we know we have the possibility to execute our own code. As a result, this exploit retrieves the administrator password of the website. Then we will test the same exploit, but with Grasp enabled, and we'll see what happens. So maybe I'll switch notebooks, see if it works. Okay. So we'll now install the original PHP into the server. I have already compiled it because it will take some time. So we restart the Apache server. And then I have the exploit takes as parameters the web server, which is a local host, the remote directory at the web server, and a valid username, a registered username, which is not required to be an administrator. So, So this will go over the database, retrieving one character at a time from the MD5 password hash of the administrator user. And well, at the end, we'll see the administrator username and the password, but we won't stay here looking at the screen until it finishes. We'll go back in a few minutes. So now it's retrieving one character at a time and telling us which character it is. So then we'll see the complete password. So the privacy threats we are facing are, well, applications handle private data from users. Sorry. And if we don't have policies to protect this data, this can lead to a privacy violation if this data is disclosed. So injection attacks can lead to this kind of privacy violation and will end at private data disclosure. So, I'll go back. So it's important to define privacy policies over the data and to enhance them. So I'll go quickly around, I will make a quick review about the most popular injection attacks. The first one is cross-site scripting, which happens when data originated from the user. It's stored, for example, in a database, and then it's output to the end user. So another user can suffer from this attack. For example, let's say I'm subscribed in a discussion forum, and as my username, I will enter this chain of characters, which in JavaScript are a simple alert, a pop-up. But think about if I post a response to a message and a user is reading my post, if my username is displayed, he will have a pop-up in his browser. But imagine this could be any JavaScript code. So This kind of attacks can happen in every web page that outputs data to a web user, all of them, okay? So we have to be aware of this kind of attacks. Another kind of injection attacks are shell command injections, which are similar to SQL injections, but this time the language used to execute a service behind the web application, it's a shell, for example. So let's say I upload the file to a web server, and as the file name, I enter this chain of characters, which are different Linux commands piped. So it will upload my file to the web server, and then it will erase the parent directory. Of course, we need to have permissions. This kind of attacks happen when the permissions are not well set, but they happen. And the final attack that I'm describing are directory traversal attacks, which the problem with these attacks are that web users are allowed to browse different directories of the web server which shouldn't be browsed. So the most common example is if a web server is not well configured and allows me to insert dots with slashes and go back into the directory tree so I could see all the files in the web server. This is a common way to describe them, but maybe we can find very difficult directory traversal attacks. So we can resume this with common principles of common injection attacks, which we have a user entering data into our application, and this data is not properly handled by the web application. So later, this data is used to execute operations behind the web application, for example, SQL queries inside a PHP application or HTML inside a PHP application. And the attacker can modify the input to alter the functionalities of the subjacent web application. So this is common to all the injection attacks. Yes? So to name some known attacks, we had multiple PHP attacks on the last years. Vulnerabilities have been reported about this. Also popular CMSs have been compromised. The one we are testing today is an old version of a popular CMS because the vulnerability is already patched. And of course, custom corporate applications are compromised every day. So which are the threats we are facing with injection attacks? So without the proper checks, any web application can allow this kind of attacks. So this, the execution of these attacks can result in different kinds of problems. We can lose data. Our data can be altered or stolen. Our content might be compromised. Also, we would suffer of defacement in some cases. Maybe someone can use our site to pivot and attack another site. And of course, we can fall into private information theft. The problem is we don't have a silver bullet to prevent them, and I don't think we'll ever have. But we can